Hello and welcome to another podcast de YH2. Today I have the pleasure to introduce you, Benoit, from Ansys, and the topic today will be about the power software Ansys and how they'll help us in these new eras of the green energy.
Great. Thank you. So let me introduce what is Ansys. What are we doing? So Ansys is an American company. We basically provide and market CAE, which is like computational aid engineering. And we are promoting as well simulations to the market. So we are first on the market to do that. And what we are helping is to help our customers for the life cycle of their product to design it, test it, validate it, and follow it along all the product life cycle of the maintenance, right? So this is basically what Ansys is doing. We are like kind of a big company. We are like 1,300 engineers right there. And this is our core simulations. We don't do anything else. That's what we do. This is our DNA, the simulations. So we are like the kind of the broadest, deepest, and more accurate software on the market to do that, to propose to the customers like an environment where they can test their product. We are always improving the models that we are using. And at the same time, we have like a deep knowledge because there's been 15 years now we are on the market and we are on top of that. So, but let's say like for the markets of engineering, what are the challenges? We see like we call it three lemma, right? And I'm going to follow what say the CEO of Baker Hughes. He mentioned that the first is to reduce our waste, like try to improve, to optimize what we got, right? The second is to make it reliable, safe, right? And the third one will be most likely to find what is the low carbon market energy, how you can create the new concept, which is using the low, that's going to emit less CO2 as possible. Okay, so where am I to talk about that? I'm Benoit Chassagne, I'm CFD engineers. I'm a lead technical engineers, and I'm leading as well the sustainability all around Europe for Ansys.
So as you say, Ansys is a powerful tool for innovation and to make optimization in the process, because that is another way to make a more green future. So that is my next question. What is about the role of Ansys for the position about the green technologies in our future?
So Ansys is really focusing on the green energy, but as well on the overall topic. So I didn't forget to mention, but we are positioned in aeronautics, aviation, automobile, healthcare, and also on energy. So what we propose is like, let me do an analogy.
Yeah.
Let's say you want to cook, you want to create a new recipe, right? And in advance, before to be cooking with different recipes, you want to test it. That's what Ansys is proposing. You are like a room when you can add all the components and you want to see how you're going to taste at the end. So all the chemical reactions is going to happen, but you don't know what will be the recipe. So you want to try different all of them, right? So the Ansys is providing a room where you can create your own recipe with your own product. Let's take an example, because we are talking about hydrogen. Today we have combustion of hydrogen. We have combustion chambers that go with normal fuel. But we want to do and see if it's happening is correct to use hydrogen for that. And instead of to do it in a real time, you can do it like in a virtual environment, where you can test it in advance how it's going to happen, because hydrogen is burning 3 times faster than the normal fuel. So you don't have the same considerations. You want to see if it's going to explode or not with the correct things. So doing it virtually is safer than to it in reality. That's how Ansys is positioning into any kind of technology for the green energy, for the green hydrogen, because you can create new innovation, but you can always test and optimize what is already existing.
Exactly. Ansys gives you the opportunity to test the bomb before the bomb explodes. It's a little laboratory, and that is the club. There is the grand deal, the big deal with Ansys. And as Ansys has driver innovation, what is the tools that maybe faster this explanation about the tools that Ansys bring up for this innovation and work? Just a little quickly.
Right. So I put that example right here. So we mentioned that hydrogen life cycle start from the production up to the usage, passing by the storage and the transportation. and you have challenges in all that domains. And if we think about the production, we think about electrolysis, pyrolysis, SMR, which is steam methane reforming. If we think about the usage, you can use combustion, or you can create electricity with fuel cells. And if you think about the storage, you need how to make the correct structure, because hydrogen needs to be transported at the end with a higher pressure or lower temperature. So all these phases of the life cycle is a big challenge. How you tackle that, that's where simulations take into place right there.
Yeah, of course, engineer, that is the one of the biggest threats. That is the transportation of the hydrogen, because it's not just move it, it's about to compress it, and all the incredible things that happen in the hydrogen that you compress. It's not just about the high temperature, it's about you have to keep it really cold, and you have to consider it about the light and everything, because all energy that he catch from the environment, it will be not burned, but increases his dimension and the pressure. So this is one of the biggest help that Ansys bring us. So what about the combustion model? For example, you mentioned before.
Right. So combustion, the challenges we have with the combustion. Actually, the hydrogen is well suited as a clean energy to be replacing the common fuel. But we don't have the same physics. We don't have the same temperature, which is burning. We don't have the same flame. The question is, can we reuse the existing one, or do we need to improve it? And once we are doing that, you still have some challenges, which are like, we can have some backfire, which is the flame which is coming back. The temperature might be too high, then the protection of the burner might be increased or changed. That's what you want to do about the simulations. And with the simulations, we are improving the different models with Ansys to create like a safer place where you can test it. That's how we
exactly. This is the one of the point, the security and validation and the technique.
Right.
Yeah, did bring off the opportunity also to improve the methodology, to explore another materials. Exactly. What about the training and the collaboration with the ecosystem?
Right. So actually, as we have like experience by 50 years of simulations, we want to share our knowledge. So we develop a platform. So we have like an Ansys innovation page where everyone can have access to it, where we can all talk together, exchange between customers or within the engineers. We do have a platform of e-learning when you can learn at your own pace and learn from our expertise, because we do use to work with the different customers, and we put into place all that expertise at the end. And with that expertise, we are developing workflows, which means how you set up the full simulations from A to B with the software that we are providing. And this expertise, that's something we're going for. Any customer wants to learn about that. And at the same time, we're creating workflow, trainings, but we have some support to share with that.
So amazing. For me, it's a big opportunity, because from when I meet the Ansys in the college, it was love at the first look. For me, it's a really big pleasure to enjoy this moment with you about the Ansys.
I don't know if you have any, because one thing like about hydrogen, you spoke about clean.
I want to talk about more in the topic of the hydrogen, because I see you have a extension tools and gamma. Well, you can tell us about Ansys and the hydrogen.
And the
hydrogen.
And the hydrogen, right. So we all know here that you have different color linked to the hydrogen. Then the one which is of interest, which is the green. The green means you are using electricity which is made out of renewables energy. So into the simulations, we have this methodology, but another one which is like, for example, the steam methane reforming. You have a whole process. What I said at the beginning, Ansys is able to make any simulations on the component level. Like if you use a heat exchanger or a compressor, you can make simulation. But you know that the whole process is a combination of everything working together. So that's a system of system.
Yeah.
So at the end, if you do simulation on one side and simulation on the other side, how you combine all of them together? That's what we're also providing a tool which is allowing you to have on one side the compressor, on one side the heat exchanger and all the other components. You bring them together and you see how it's going to behave at the end. So that's just not a component system level, but this is as a higher level of system where you can combine all of them. If we take an analogy, Could be like with a car. If you take the light, if you take the battery, so on, at the end you want to simulate the full car.
The full environment, yeah.
Right. So that's as well another dimension that we are providing with Ansys. But today you wanted to know about as well the innovations we are providing to our customers. We all hear about the capacity of the computers today. So all the models that we are using, they are nice, but we are limited by computer power. But we hear today about like what we call GPU, graphical process unit. We all hear about we have a nice, let's say, partnership with NVIDIA, but we all hear about NVIDIA creating these GPU chips. And with the GPU chips, you can do the same thing as before, but faster. And then we can do even more. So that's how we help our customers to go faster to the market, because the power of the computational computers are improving, and we are basing our models thanks to this methodology. But not only, because I think you wanted to mention as well that we have AI. What about AI? We are all informed about AI, right?
Everyone, yeah.
So we know what we know about AI is like LLM, which is large language model, which means like you ask a question to ChatGPT and you have an answer. Right, that's the easy way, but we do it apply as well to the technology. Why and how? So we are able to use AI. Let's say you have a model, you don't really know how to set up your model, right? So with the AI, you can pretty much set it up in advance, like the best suited model that you want to simulate. So if you want to democratize the simulation to someone which is not really aware of that, you can help them thanks to AI. But not only, because when you do simulations, how we can trust into simulation? We can trust into simulation because we know that if we compare the simulation to the real results, we are close to 95% of the precision, right? You can create a model based on data as well, and we are next close to 93%. But the good of AI is like you can combine the data and the simulation all together to increase the precision of your results up to 98% of it. That's the idea. So when you do the simulation, you can have this, but we can go even further for that. Today, we are saying about what we call digital twin, and we participate how to, let's say, promote the information, how we share the information around others. So we created the digital consumption where we are promoting the digital twin. So what is a digital twin? Actually, if you take your fuel cell, because we are speaking about hydrogen, you take your fuel cell on one side, or even the burner. Let's take a burner for this case, because I have a good example to share with you. If you take the burner, you want to see what is happening inside. You don't know how much hydrogen you want to put inside. What should be the length of the flame, right? In reality, what you need to do is to put some sensors. But the issue with that is like, first, the sensor is very costly.
Yeah.
And if you want to put a sensor what is burning, not sure you have one for that, right? So the good thing about simulation is like you can put virtual sensor anywhere, and this is for free. You can put as much as you want there. So in this idea, what we want to do is like, you run your real asset, which is a burner. You make a virtual asset of it, which is simulation, and you connect them in real time. That allow you at the same time to know how much hydrogen you need to put inside your domain to have the correct length of the flame and the correct temperature of it. That's what we call digital twin. So we are proposing this tool to our customers where they can in real time control, which means at the end, if you're able to put as much hydrogen that you need, no more, no less, you are optimizing it. And at the same time, you are reducing the waste that you can have behind. That's the full idea that we can see about the simulation.
So as you can see in my face, I'm really happy because I meet this great man today. But for me, they told me like we know a long time, because all that they say is the day of an engineer and of this work. It's because I don't know what's happening in the middle. I just know I have this from this size that is like okay, I need to burn hydrogen. I have for this size the idea that okay, I need 100 degrees and water, one oil, one something, what I get in the middle. One of the important things that you say is about you have to simulate that flame, that sensor. The sensors are really expensive. And also there is, for example, I usually work more in the mechanical part. I mean, for example, the torsion in the Ansys. Ansys ring us at all, for example, to predict that torsion flexion, that torsion force. And usually you can do that because for that you have to put a sensor inside the shaft, inside the turbine with all burner. It's impossible. That is, for me, it's like it's really incredible for me. And this is just something normal. It's something old for Ansys. For this reason, it's more fantastic that also they have this improvement about to say more easy about the idea of the AI. I mean, there's GPU that make the task in parallel to make that idea. Another thing that you talk about is that the first time that you meet Ansys, I never forget that they come in the teacher and tell us, guys, I'm really so sorry. This is a black box. You don't know what is coming in, you just know what is coming out. But this is just at the beginning. I'm really happy to know that Ansys don't have this idea that I will do it, but I don't will tell you how. No, Ansys good the way to work together to improve in every single day. For me, this is a part of the magic. This is one of the biggest things that make Ansys a great company and a great tool and a great friend at the moment to affront the difficulties. And also we talk now. Well, we have been talk about the gray hydrogen that is the regenerate that usually coming from exchange of process. What about the famous green hydrogen? I mean, maybe more about the hydrogenerate, because Ansys is multi-physical ways. I mean, it's not just for mechanical, it's just not for thermical. For example, for this process, the electrolyzer is a combination of the pressure, temperature, but also electricity. Is multi-physical. Maybe we can talk a little bit more about the green energy. That is what is now is the essential.
Right. So quickly on the clean energy, on the green. The good point of the green one is because we already know the physics already there. The fuels, we know about the fuel cells. The thing is, like, you still have some challenges in there, but that's great because at the end, green hydrogen just produces water. It's not emitting any CO2. That's the idea, which is great, but still have some challenges with the fuel cell. And as you mentioned right before, which is really important, is like how you can use the software, how we democratize it. Like, we are developing the interface that anyone can use it. And let's say you are the expert and you want your colleagues to use it, but he's not an expert. So you can create the model, you can create an app, like an application, and just let your colleagues just use it as it is without having everything known about the setup. So you are the expert, but even your colleagues can use it because you made it for him. And then that's what Ansys is promoting. And one thing that you mentioned as well, which is very important, that's the safety, of course, with the hydrogen. And we are planned. So there are some regulations we need to look at. So how is it going to burn? And we are working on the new models because not everything is defined up to now. So we are partnering with universities. Like Ansys is partnering with more than 3,000 universities in total, and we are developing the community about how we can do. I think there's a university in Ohio which is working on the corrosion part of the fuel cells, or a university in South Carolina which is doing about the batteries. So we are constantly improving our models with a partnership with universities, but as well we are promoting any startups. So any startup which is doing like solar panel, hydrogen, everything which can help to bring our Earth like a better place to live, to emit less CO2. That's what we are trying to do. So yeah, I'm really happy to show how we can do, and anyone which is willing to challenge us about any topics on hydrogen specifically, I'll be more than happy to help on that.
Good. What did you say? One of the audience have a question.
Hi.
Hi.
Interesting. Okay. Well, I am PhD candidate. I am developing a thesis based on the photocatalytic reaction
Right.
to produce green hydrogen, and I would like to know which Ansys model have the capabilities to simulate this reaction, this photochemical reaction, and what example, if you have other models that I can estimate the behavior of the catalyst.
Right. So let me rephrase. Maybe I don't know if we catch up the question. Right. So let me rephrase. So you're a PhD student and you are like trying to know how say it again the name. Photocatalyst reactions, and you want to know if we have any models to deal with that. And what is my question is like what you would like to see there? What you would like to analyze?
I would like to know the performance of the reaction.
The performance of the reaction, which is behind.
Yeah, I have to build a prototype. Okay.
Okay.
But obviously, if we have this tool, we can estimate before to start the hardware.
Exactly. So you want to estimate the prototype of it. So that's a good point. Simulation is made for that. So if you want to create it, to be honest on the question, I'm not sure that we have exactly we are looking for. We are different models. We are different models, which is on the fuel cells, right? So we do use like what we call PEM, which is protonic exchange membrane. We are doing the same with anode exchange membrane as well, which is the new methodology using hydrogen and water liquid. And we have the old one, which is the solid oxidation part of that. And the two new things we are using, but actually that maybe the challenge you may have as well. This is how you have the surface interactions with the anodes, no? In your case.
For this, in the past I worked with mechanical engineer.
Okay.
Was hard, but now I don't know why I am still no, but okay, but
it's a good question, for everyone. But the important is to
I am seeing totally new, different. I don't know, 15 years ago, and Ansys is totally different. The interface is totally different. More,
it's more handy.
Yeah, good work. But I am involving now.
Right. So if I'm trying to rephrase from microphones, yeah, you are a mechanical engineer, and then you wanted to do a little bit more and learn from that, which is nice because, as I said, we have a platform to learn about that. So I'm a CFD engineer initially, but I learned about the mechanical side as well. So you can learn the CFD part as well. And if you have a colleague who knows the CFD, you can both integrate that in the same interface and develop the model that you want to use. That's something. And as you say, the interface is kind of handy because we don't like to democratize it. We don't like being used just by engineers. We want you to have it used by everyone. Because we think that having simulation is a nice tool, nice game to play with. For me, it's kind of magic, right? But the thing is, like, it's gonna save time actually, and you can make a different prototype, and you can save as well the amount of weight that you're gonna use. That's the interest. So could be, and I think I can end with that. Like could be like any innovations you want to do. You have any idea you want to test it before virtually speaking instead of to create it. You have already a product which is used. You want to optimize it. Try different parameters. You change maybe the boundary conditions. You change the temperature. You change the geometry. You can do it virtually with that.
Yeah, the geometry I have it that I left with your partner for that because it's my reactor has 2 units. One is I don't know how to say. It's a photo optic module because I need to use some light. I don't know at the moment if it's sunlight or artificial light. I am investigating that, but I need to activate the catalyst using a photo.
Right.
Use the light, basically.
Yeah, exactly.
I think I have a colleague like we can expert on that. We can talk outside of the podcast maybe if you want to go to deep further like that. But I'm sure we can do that. Thank you very much for the interview.
Thank you very much for the opportunity, my man. It was really good.
Thank you very much.
About to talk about this love and this bigger software. And thanks for the opportunity.
Right. Thank you very much.
Thank you very much.